Hello one and all, hope you are all having a wonderful time. I am Divya, one of the Chief Instructor of Open Fun Innovation Lab, Bangalore. Now, there was a scenario when we were UG students, what we used to do when we wanted to get some information. We used to go to the library, or even easier case was using Google. Just Google, get some information. Now, the scenario has changed a lot and it has become more easier, I can say. What we are using, we all know, ChatGPT. The transition has also become so smooth that we hardly realize that there has been some kind of transition involved with respect to accessing the information. Now, there is also a scenario where you might have encountered when you are using some large language models like GPT. What happens? You are getting the same answer over and over again, which makes you use different kind of prompting or leave that and take it some other day to do the same task. Now, what happens if there is a scenario that context is still retained? We are not forgetting the context. So that is where instead of large language model, we have large context model. And there is a very interesting paper where I have put in the description. You can go through that in your free time for a more easier understanding. Now, the use of this kind of GPT models has become so exponential that we should also know what is the basic design principles behind them. Nowadays, we are using all these tools as a part of our work, but we don't know what is the basic principle, what is the design principle behind them and all. So today's topic is about diving into the world of large language model and large context model. How do they differ, why they matter, and how they are going to impact. Let's dive into the video.
Today's topic, large language models and large concept models. Like, share and subscribe. First, we'll see the landscape of large language models, what we have seen. Even without knowing what is a large language model, it has become an tool for our everyday work, especially among the students. So I don't say only students are using it. It is used by each and every one of us for one or the other reason. So when I'm talking about the landscape of LLM, we have two types. One is open source LLM and the other one is closed source LLM. So in open source, we will say something called as Llama, Mistral, Loom, Falcon. In closed models, it is more famous. It is Gemini, ChatGPT, Claude. So what is this open source and closed source models? Usually, these open source LLMs, they are characterized by the public accessibility. What do you mean by that? In the sense, you can inspect their code, identify the flaws, suggest any kind of improvement, adapt your model for the specific purpose. Whereas in the closed LLM, usually they're developed, maintained in a closed environment. They're usually subscription based, means you have to pay for any kind of specific services you want to use, or they will have a daily limit on that. And access to the underlying code and training data is always restricted. Usually they are like black boxes. We don't know what happens inside them. So these models are like black boxes to the external user. So what is the fundamentals that led to these kind of very advanced AI models? That all started with the groundbreaking paper called Attention is All You Need from the Google research team. Usually, they made something called as transformer model, where our model focuses entirely on an idea called as attention, where only relevant parts of sequence are made to be more and more focused, ignoring the need for the traditional recurrent neural network or convolution neural network. And then we had only encoder only architecture, which is usually found in BERT kind of model. So what happens here is it is usually bidirectional. So they don't process any kind of text sequentially. They have positional encoding where a word order is retained. And in this, the attention is not masked. It can look at the words in the all the direction. All the direction in the sense either from left to right or from right to left. Then we have GPT models. This has decoder only architecture where our masking prevents looking ahead, means ensuring words are predicted sequentially. So here the focus is more on the previous words. So the language processing happens from left to right only. So where did we get the concept of this large concept model in the sense, supposing in our LLM, if I feed any kind of sentence or a paragraph, they are not taken as is. That sentence is broken down into words. These words, what you see, they're all called as tokens. This happens even before the data cleaning. So as you see in the example, this kind of processing of the text happens word by word, or in this language, we call it as token, which limits our understanding of the context. So if I want to process the text in more and more larger concept where the context is still captured, then I have to make it into a phrase. So our large concept model come into picture in this situation only. So as you see in the example, instead of only taking quick brown fox separately, I have taken the concept together. Quick brown fox as one context, jumps over as one context, lazy dog as a context. So another beautiful example, what you can see in the paper, which is given by them, I have given as a reference as well. See, on the left hand side, you see the statement example. Tim wasn't very athletic. He thought that it would change if he had joined a sport. He tried out several teams. He did not make the cut for any of them. He decided to train on his own. So instead of that, it is completely changed as because he wasn't very athletic, Tim could not join the teams to improve. So he decided to train on his own. This is the context taken, or in the embedding space of concept, this is how we have taken the fundamental context taken. So on the right hand side, what you see, our encoder and decoder has been fixed, and this is how our context has been taken. So what are the main characteristics of this kind of LCM approach in the sense? They can think beyond words and picture, means you can think of combining the data in the form of text, image and sound rather than processing them separately. So instead of analyzing the individual words or pixel in isolation, it can build a more structured knowledge similar to how we humans think in the terms of topic and subtopic. It can handle extensive data like long documents, narratives or conversation, while still the focus on the essential details is being maintained. So when there is an unfamiliar situation, it can still generate the solution on spot without needing prior example, and they are easily adaptable and scalable. Means our AI systems can be integrated without requiring a complete redesigning. So how interesting is this?
Hope this was an engaging video. Now, can I say the gap between the large language model and the search engine has become so narrow that we don't know. The search engines will be evolved more and more in the upcoming future. Only time can say that. Like, share and subscribe. Stay tuned for this channel for more such interesting content.